Okay. So let me share my screen. My screen is visible, right?
Yes,
Yes, sir, it is visible.
minimization of Boolean expression.
Yeah, correct. So today we'll see minimization of how you minimize the Boolean expression, right? So we'll solve some problem also. So first there is a certain rule like if you do you do it or with any with sorry, if you do x or 0 then it will be x, and that dual x dot and 1 equal to x or 1 will be 1, and that x dot 0 will be 0, right? And there is another law if you do x or x it will be give x and x and x it will be give x, and there is another law if you complement the if you do double complements like x complement you will get the x, right? And there is a x or x bar equal to 1 and x dot x bar equal to 0, and there is a commutative law x plus y equal to y plus x, and then x and y equal to y and x, right? Just axiom, right? Then there are certain associative law, right? So x or y or z equal to x or bracket y or z, right? So there are some basic law, right? And that is a very important de Morgan's law, right? So what de Morgan's law says, like x plus y equal to x bar dot y bar, and there is a another x dot y bar equal to x bar plus y bar, right? So let me solve some question. So you have to minimize the that Boolean expression, so right? So from that you can that xy plus xy bar, right? So we can take common x, right? So we can take x, then y plus y bar, right? And we know that y plus y bar equal to 1, right? So we can see that here that x plus x bar equal to y, right? So it will be 1, right? So this will be 1, so it will be x. Okay, now let's solve second problem. X plus y bar, right? So you have to first, so x and x, then plus x y bar plus y x plus y bar, right? Now you can say that x dot x will be x, right? So this will be x plus xy bar plus yx plus this will be y dot y bar will be 0, right? This will be 0. So this will be 0, right? So we are getting x
And
plus,
again, yx will be xy only.
yeah,
And
x,
again, we can do that xy bar plus xy equal to x only. And x
yeah,
plus
correct.
x equal to x.
So we can take common x. So it will be like x, y plus y bar. So this will be again 1. So x plus x will be again it will be x. Okay. Now we'll solve next question, right? So this is x y z plus x bar y plus x y z bar. Now you can there's you can take common xy and xy, right? So you can take common xy. That will be z plus z bar plus x bar y, and it will be like 1, right? So xy plus x bar y. Now we can take common y, so it will be y x plus x bar. Again it will be 1, so it will be 1. So this three problem, any doubt?
It's clear.
Okay. Now this is I think practice assignment questions. So write the reduced form of the Boolean expression. So Boolean expression given, so you have to find the reduced expression, right? So what is the expression? The expression is given a b bar c plus bd plus a bar dot b bar, and there is a this c, right? C. So first you have to, it will be like a bar a b bar c plus a b bar b d, right? And this will be a bar b bar c. Now you can see that b dot b bar, this will be 0. So it will be like a b bar c plus a bar b bar c, right? Now we have to multiply a b bar c plus a bar b bar c. Now you can take common b bar c, right? B bar c a plus a bar.
This is because C will be C only.
Yeah, c and c will be c only.
Correct.
Okay, so b bar c, this will be 1, so it will be b bar c. So third one will be the correct. Everyone got it? Okay, now we'll move to the next problem. Find the numbers of literal required to represent the given Boolean expression. So you have to find the numbers of literals required to represent the given Boolean expression, right? So what is the Boolean expression given? A bar b d bar plus c bar d plus b a plus a bar c d, right? So you have to find the like numbers of literals required, right? So you have to find the, you have to minimize the expression, right? So let's minimize the
So
expression.
basically, it is asking whether we need or all four A, B, C, D, or after simplifying, it may become something between B and C only.
Yeah,
In that
correct.
case, number of letters will be 2.
Yeah, correct, correct. Okay, so you have to find the, so let's simplify a bar b d bar, and this will be like a bar b c bar d, right? Then this will be a b, this will be a bar b c d. Okay, now we can see that a bar b d, you can see that this and this we can take common. So a bar b d bar plus a b, we can take common a bar b d c plus c bar. C plus c bar will be 1, right? So it will be a bar b d bar plus ab plus a bar b d, right? Now you can see that a bar b and a bar b we can take common. So it will be a bar b d bar plus d plus ab. Now we can see that d plus d bar, it will be 1. So a bar b plus ab. Now we can take common b. So b, it will be like a bar plus a. So it will be again, it will be 1. So it will be b. So numbers of literals required is 1.
Okay, now this is like we have simplified the expression. Now, what is the meaning of this kind of expression? I mean,
So
apart from the math, what is the meaning in terms of circuit?
okay, suppose in circuit given, so can you minimize the circuits? Suppose one circuit, suppose this is doing something. Now question is, can you minimize the circuit? Because if you see there is lots of not get, not lots of AND gates and lots of OR gate is required, right?
Yes,
But can you simplify the circuit?
yes. After simplifying, it became B only.
So it will cost will be reduced, right?
Yeah, basically I was asking why such a big expression or circuit was there in the first place.
Okay, suppose like for performing some operation or perform you are if you are doing some things like some logical or and you are writing, you are not focusing on the simply like optimization, right? Whatever you are like mind is coming, like you are just writing. Now next thing is like after
Okay,
creating the
understood.
circuit, can you simplify?
Correct.
Okay. Okay, now you have to choose the correct option, right? So you have to simplify the all the given option and you have to choose the correct option, right? So let's do first one, x plus y whole bar, x plus y equal to 1 or not. So what we can write, x bar dot y bar by De Morgan's law, x plus y, right? Now you can see that x bar dot x, this will be 0, so it will be 0. So this is not correct, right? So this is giving the 0 and this is also giving the 0. So this will be the correct, right? So in that way you can check all the things. So let's check fourth one, x dot y plus x dot y bar equal to x or not. So you can take common x, it will be y plus y bar, it will be x. So this is right, right? So yeah, so this question is clear.
Yes.
Okay, so now next question is saying apply the De Morgan's law. You have to apply the De Morgan's law and identify the minimal expression. So you have to apply the De Morgan's law and you have to identify the minimal expression, right? So what is the expression? A bar plus b dot c plus d bar, right? So this is bar, right? So you have to apply De Morgan's law. So it will be a bar plus b plus c plus d bar, right? Now again you can apply De Morgan's law, right? So it will be a bar dot b bar plus c bar plus it will be dot, sorry, it will dot d bar d, right? So it will be, you can see that by involution row a bar, you can see here uh, x bar double bar equal to x, right? So you can see that this will be a dot b bar plus c bar dot against involution law d. So this will be the correct. Okay, so the next question is, consider a system where we have input x, y, and z. We have two inputs or gates, two input and gates, and not gates. How many minimum numbers of gates are required to implement the circuit for the min-term expansion? So there is a circuit is given, like min-terms is given 1, 3, 4, 5, 4, 7. You have to find the like you have to first find the minimal expression, then you have to tell the what is the minimum numbers of gate required, right? So it's given 1, 3, 4, 5, 7, right? So let's write. So let's write the first truth table. So truth table is given, like you have to write the truth table x, y, z, and f, right? First is 1 is given. So what do we know 1? So 1 will be f is 1 is like 0 and 0, 1, right? So 0, 0, 1. So this min term is given. So 0, 0, 1 will be x bar, y bar, z plus 3 is given. So 3 means like that 0, 1, 1, 0, 1, 1. So 3 will be like x bar, y, z, right? Now 4 is given, right? 4 means like 1, 0, 0, right? So this is given 1, 0, 0. This will be x, y bar, z bar, right? Now 5 is given. 5 means 101, I think. Yeah. So 5 is given. So 5 will be 1 101. This will be x y bar z. Now 7 is last one. Right? So 7 will be 111. So it will be x y z. So this is 0. This is, so this is 1. This is 3. This is 4. This is 5, and this is 7. Right? Now you have to minimize the given Boolean expression. Right? Okay. Now we can see that, say that if you take common z, so it will be, you can see that z here, like z here is common, z here is common, and z. So 4 in 4 min terms z is common. So you can take z is common. Right? So it will be x bar y bar plus x bar y plus x y bar plus x y plus x y bar z. Right? Now you can take like a z is given. Now you can take common like x bar, right? So it will be x bar y plus y bar. Now we can take here's common x y bar plus y plus x. This is x bar, sorry. This is x bar yz. This is x x bar y bar is 5, right? So x y bar z bar. Yeah. Okay. Now this is 101. Yeah. Right. So now it will be x y bar z bar. Right. Now we can say that z x bar, this will be 1 and this will be 1, right? So x bar x plus x y bar z bar, right? So this will be z, x plus x bar equal to 1, right? So z plus x y bar z bar, right? Now you can there is a one I'm writing here, x plus x bar y equal to x plus 1. How this come? You can x write, you can x dot 1 plus x bar y. Now for 1 we can write x 1 plus y plus x bar y. So you can write x plus xy plus x bar y. Now we can take common y, right? So x plus y, x plus x bar. So it will be x plus y. Now here you can see that z plus x bar. So it will be z plus x y bar. So what is the numbers of get is required? Anyone? So for not, it will require 1 gets, and for this it will 2 gets, and for or it will require 3 gets. So total numbers of get required is 3. Hello, any doubt in this question?
If possible, could you please repeat and explain the problem statement?
Okay. Consider the systems. So we have a one systems where we have a inputs x, y, and z, and they are given like we have 2 inputs or gets, we have 2 input and gets, and there is a one like not gets, right? So there is a how many minimum numbers of gets are required to implement the circuit of for the min term expression. So Min term expression is given summation of 1, 3, 4, 5, 7. So you have to tell find the numbers of get is required. We have OR
So
gets.
basically, as a resource, so these five gates are the resource given to us.
Yes, like OR gets, NAND gets, and on like NAND gets is given, and AND gets is given, and OR gets is given. You have to
Mhm.
find the numbers of gets required.
No, what is the meaning of this min terms expression summation 1 3 4 5 7?
Yeah, summation of 1, 3, 4, 5, 7 means one seems like in binary, how we can write 1 means 0, 0, 1,
Okay.
and 4 means in binary you can write 1, 3 is there. So 0, 1, 1. This is 1, this is 3. And 4 means 1, 0, 0. This is 4. 5 means 1, 0, 1. This is 5. And 7 means 1, 1. So min term
Okay.
is like that. So 1 means 0, 0, 1 means x bar, y bar, z. So I have written x bar, y bar, z. 3 means 0, 1, 1. We can write x bar, y, z. 4 means 1, 0, 0. So 1 means x, y bar, z bar. 5 means 1, 0, 1, x, y bar, z. And 7 means 1, 1, x, y, z. Okay, you got it right? Bimiles? Hello,
We
am I
can
audible?
change the order of x, y, z also,
So,
or
see,
this table is given in the question itself.
no, no, it's
I
not
don't
given.
think so.
It's not given. So, I've taken like, yeah, you can change x, y, z also.
Acha, x, y, z we have taken basis our own convenience. It's not
Yeah,
given in the question.
yeah, correct.
Correct. Okay.
Okay. So, so week two, I think basically that SOP is given like sum of product, all the things is given, and minimization of Boolean expression, right? Okay, so any doubt in week two?
Yeah. I think we should be able to solve questions now.
Yeah, so I'll suggest first try to like solve practice assignment question, and if you have doubt, you can just post in the discourse or you can ask in the Google like the chat na, so you can ask directly to me also. And
Sure,
if you are,
sure. Yeah. There is
if,
this Google space created for CSB. We can ask
uh,
there also.
and if you have any, you can ask directly to me also if you have any
Okay.
doubt.
Okay.
And yeah, like you can
So
post in the
on
discourse.
Discord we can post and tag you. Post on
Yeah, yeah,
Discord and tag you. Okay.
yeah. I'll answer all the questions. And after that, try to solve graded assignment question. So if you are able to solve practice assignment question, it will be easy for you solving the graded assignment.
So this today's this whatever we have solved today, how can you share with us
I'll upload in the that YouTube and I'll share the link.
in YouTube? Okay, I mean the calendar you are saying.
Yeah, in the calendar I'll update. Not yeah, I'll update in the calendars.
Okay, okay.
Okay. Okay. So Sanjay Kosta Kumar. Yeah, Kumar. Do you have any doubt? You raise hand.
No, sir. No, sir.
Okay.
No, no, no. I wanted to add the point Vindesh asked that time, right? That circuit, what is the meaning of to reduce the circuit? That's why I just.
Okay. Okay. You can add your point like if you want to add anything.
Okay, so there was one more point there. So whenever we create some circuit, so there is a lots of wire goes. So every instruction, whatever the circuit has written, it's go through the wire. So whenever we create some chip or the some circuit, so due to the lots of wire, no electromagnetic induction also create and which affect the near wire. So we mostly try to sometime reduce the circuit in the lowest format, so we can care about the space and that the electromagnetic induction also apart from the cost. That's I wanted to add.
Yeah. Thanks, Kumar. Thank you very much.
And that's happened in the robotics, or that the designing the motherboard, or that designing the some chips, this type of things. So we always try to find that sometime. And also sometime it is helpful quietly in that programming idea, whenever the if we are able to convert our so much condition in the circuit, and the circuit solve that, and the last whatever the option we got, and put the programming also give the best result. So this is also, but generally till now it is used more in the circuit area.
Yeah, correct. Thanks, Kumar. Yes.
Yeah, thanks.
Okay, so Bimlesh, Sanjay Kumar, if you have any doubt, you can ask. Otherwise, we can bind up the session.
No, I'm done. Thank you.
Okay. Thanks for joining. Thank you very much.
Thank you.
Thank you.
Okay.